Okay, so we are now constructing an angle bisector. A bisector is something that is cut in half. So, again, I'm making just any angle. It doesn't matter what angle I make. There we go. I have myself an angle that I can bisect. So the first thing I'm going to do is I'm going to make an arc. Try to keep in mind which point you're using. So I'm going to use the point between L and P. So I use the point between L and P. It doesn't really matter. So one of the things that you need to do is make sure that you're going more than halfway between these two marks. So I'm going to set my center right on this vertex or this intersection point. And then I need to go at least halfway. So I'm going to go between P and T again. And I'm making an arc out here in space. So I just use the point between P and T. So then I'm going to use that same point. I must use that same point between P and T. And I did. And now I'm going to use my straight edge to connect the X to the point. And there we go. That is an angle bisector. So if this was 35 degrees, then this is also 35 degrees. A bisector cuts an angle in half. Okay? So we cut an angle in half. Let's go ahead and do it using the standard compass. So first you would use your straight edge to form an angle. Doesn't matter what kind of angle you make. This one's a little bit smaller, I think, than that one, but that's okay. Doesn't matter what size you make. Make sure you get your point on there, and then you want to kind of make sure that this is in a position that's not going to shift a lot, which is really bad for this compass. This compass seems to work better as it gets bigger, so that's unfortunate. So we're going to go ahead and make our arc. Go ahead and make an arc out in space. Go ahead and make another arc. And it made an X. We went from here, made the arc, from here and made the arc. If they're not touching, if they don't reach each other, then you don't have it open enough. If you have them closed and you make your arc, right, and then you make another arc here, they wouldn't reach. So you have to go at least halfway between these 2 points. At least halfway. You have to go more than halfway so that they touch. If they don't touch, they won't make the X. So we need that X. And then you'll use your straight edge to connect the X where they crossed to the vertex. There we go. And there you go. We've got our angle bisectors. So maybe this is 27 degrees and 27 degrees. So there you go. A bisector of an angle just cuts an angle in half. So that's an angle bisector. That was number 2. Number 3, construct a segment bisector. So the first thing you want to do is construct a segment. So go ahead and draw yourself a segment. Give it some ends. Okay, we want to cut this segment in half. Bisector means to cut directly in half. So the first thing we're going to do is we're going to get our center on the end, one of the ends. We're going to pick a point more than halfway to the end. So the end is over here. We need to go more than halfway. So you can eyeball that, but it looks like right before F1 on mine is more than halfway. And I'm going to make that arc nice and big. Okay? So almost half a circle. And I use the point right before F1. Right before F1. So I'm going to use that same point right before F1, but I'm going to put my center on this end now. This end. Okay? And the point right before F1, which was this point here. Okay? It's made kind of like a fish or an eyeball, and that's fine. I am going to connect the dots, connect the X's. So I've got an X here and an X here where they cross, and I just have enough length on my compass to use it as a straight edge. So connect the dots, and there we go. This is the segment bisector. Not only that, but we have constructed a 90-degree angle. This is a 90-degree angle. And we've also constructed what are called perpendicular bisector. So that is a segment bisector. Segment bisector is actually, if you do it this way, it's actually a perpendicular bisector. So that's nice. It's cutting it right in half. So we cut this segment here from point A to point B. If we said it was 1 unit long, then from point A to point C is also 1 unit long. And we can identify that C to A is the same length as A to B by putting a little dash in there. 1 dash means that they're the same length. A 1 and a 2 would mean that they're different lengths. So a 2 and a 2 would be the same length. We can also say the same for A to D and A to E. A to D is the same length as A to E, but A to E is not the same length as A to B. So that's why we would need different types of dashes. So 1 dash means that these 2 segments are the same length. 2 dashes means that these 2 segments are the same length. So that's fun. All right, so that is a segment bisector. Let's go ahead and do one more segment bisector using the standard compass. But it should be the same, and hopefully it'll make sense. So we'll make it a little bit smaller this time. So we'll do a small segment bisector using our compass here. You can go pretty large with it, but you just need to go more than halfway. Halfway is not good. You need to go more than halfway. Okay, and then we're going to flip it around and do the same over here. And then we're going to take our straight edge and connect the endpoints. And that is a segment bisector. Again, we bisected these 2 segments. And in the process, we've also found another segment bisector. These 2 are the same length. So that's kind of fun. All right. So that's the segment bisector. That was number 3. Number 4 is an equilateral triangle. Equilateral triangle. So I've never done an equilateral triangle with one of these before, so it'll be kind of fun. We need to, let's make a segment first. Okay. We need to find exactly how far out we are. So it looks like O, for me, O ends up being perfect. So I'm actually going to do a full circle using O. And then I'm going to do a full circle using O again. Uh-oh. Which O is it? The before or after O? O. The before O. Okay. Okay. So the before O. Make sure I'm on it. Pretty good. Okay. The before O. There we go. There we go. That's good. And there we go. And we got ourselves an equilateral triangle from this point here. I can connect this point to each of the ends. What I have constructed here is all three sides are the same length. All three angles are the same angle measure. That is an equilateral triangle. Okay? So you can do just a point and not a segment if you want. And that will work as well. And then pick a point on the circle, anywhere on the circle. And then draw another one. Make sure it didn't move. It didn't, so that's good. Okay. And then our third point would then be right here. And then connect your three dots. And you'll have an equilateral triangle. A couple of different ways to do this problem. But the main thing is that you need two circles, or two portions of a circle. You really don't even need the full circle to make this happen. If you notice, there's another equilateral triangle that connects to this point. But all three sides are the same length. All three angles are the same measure. This is an equilateral triangle. So the two different ways to construct it. Okay. All right, that is equilateral triangle. Next is the perpendicular lines. So we want to construct perpendicular lines. That actually was already done, but we're gonna do it again. So sometimes the wording makes it funny. So construct perpendicular lines. So again, we want to be more than halfway. We're going to make our arc, lift off, place on here, connect the two intersections, this one here and this one down here. Kind of like in art, this is precision. The more precise work you do. And we have perpendicular lines. Perpendicular lines are lines that cross or intersect at a 90-degree angle. So since we've got four 90s, that's a perpendicular line. Let's go ahead and construct one more perpendicular using our spinning compass. So the first thing I would do is draw a segment. Then we need to put our center on one of the ends and pick a point that's more than halfway. And it looks like the point right before L is more than halfway, so we're going to use that. And it was right before L. I'm going to flip it around over to here, and we're going to the point right before L. All right. Connect the X's. And there you go. Perpendicular lines form a 90-degree angle. So, way to do it with both. The last thing we're going to do is construct a 45-degree angle. To construct a 45-degree angle, you have to first construct a 90-degree angle. So we've got to do that again. So we're going to construct a 90-degree angle. We've got our ends. We just need something past 1/2 of the way. So it looks like the point right after P should work fine. Point right after P should be fine. Okay. In this case, I'm going to set up my two X's, yeah, so that I could make a line all the way through, but I'm not going to make it all the way through. I'm just going to go to there, okay? You could go all the way if you want. You can go all the way down, totally fine, but I did line it up with the bottom as well as the top. So this is a 90-degree angle. I want to bisect 90. If you bisect 90, 90 divided by 2 is 45. And that's what we want, is a 45-degree angle. So I'm going to, I use this, so let's continue using this. Let's see. So here's another way to use this compass, so we'll show it. Is you can hold the blue instead of the white and then pick one of these points and spin. Okay? So I just picked the furthest out one. So now I'm going to go here to my arc mark, and then I'll do the same over here. So I'm going to just go to my furthest out again, which is this one here. And then I'm going to bring it over here and do my furthest out one. Okay, and X marks the spot. So I'm going to connect that to this point here. I'm going to keep it where I want it. Okay. And there you go. This is a 45-degree angle. It's a bisected 90. So if you bisect 90, you get 45. So we got ourselves a 45. This is also 45. So, and actually, this is 45 as well. So we actually have multiple 45s, but we only needed one, and we have it. So let's go ahead and see how we do it with a regular compass, for those of you who have a regular compass. So to construct a 45, we're first going to make a segment. Then we're going to go a little more than halfway, which ends up being about there. And then we're going to flip it around. Use your straight edge to connect the dots. Okay. I could go all the way down to this point here, but I'm just going to there. I did line it up, though, so that it would work out. Okay, so I've got a 90-degree angle here, and I'm going to bisect it. Oh my goodness, it just slid. Wasn't too bad though. Okay. And then I just connect my X. And I've constructed, and I wrote 40, and I've constructed a 45-degree angle. So both ways. So those are the 6 different constructions that we're going to do this week. I recommend that you practice them. Try a few of them. So we've got number 1, copying an angle. Number 2, constructing an angle bisector. Number 3, constructing a segment bisector. Number 4, constructing an equilateral triangle. Number 5, constructing perpendicular lines. And number 6, constructing a 45-degree angle. There are much more constructions out there than just those 6, but those will get us started. If you have questions, please let me know. Thank you so much.